Hi there, this is exercise 5C. We're going to look at partial fractions, or technically the method of partial fractions. Now, partial fractions it's the opposite of adding fractions. So before I can do that, I just need to remind you of adding fractions. When you add two fractions together, you make sure you have the two denominators on the bottom. It's called a common denominator. Now, when I do this, the 3 was over x minus 2, but it's gained an x plus 1. So effectively, it's got to have an x plus 1 on the top as well. And likewise, this cross multiplying is quite a useful technique, and you can then tidy it up. I've got 3x plus 2x is 5x. 3 minus 4 sounds to me like 3 minus 4 is minus 1, all over that double bracket. Okay. When you have two brackets, it's like that. When you have three brackets, it's the same idea. You want to put it over all three denominators, but obviously you've got a little bit more work to do. And that only comes from the fact that when initially the 2 is there, and then if I put it was over x plus 3, but it's now got all these three things. So effectively I need to have both of them coming over to it. So it's 2 lots of x minus 4, x plus 5. Plus, well, technically 1 x plus 3 x plus 5 I need to gain, minus the 3, and it's these two this time, so it's x plus 3 x minus 4. So what's that give me? Well, I shall write 2, and then it's everything in that bracket, so it's x squared, I think, plus an x minus 20. I can ignore the 1 now. I think it's plus an x squared plus 8x plus 15. Oh, it's a minus on this one. Minus 3 lots of x squared minus x minus 12. All over that treble bracket, which I can't be bothered to write. And if I just do the top of this, I get 2x squared plus another on it, that's 3x squared minus, alright, x squareds go. I've got 2x plus 8x is 10x plus 3, I think it's 13x left over. And the numbers, I get minus 40 plus 15, that sounds like minus 25, minus a minus, plus 36, I think that's plus 11. All over the triple bracket. I suppose my final answer should be a bit better and write it properly. So that's how we add, and as you saw there, subtract fractions. And our job is to do the opposite of that. And by that I suppose I mean, let's just check my answer. Yes, that's right. My job is to go from, if you remember, these initially to this. I'm going to try and work backwards. And so I've picked one here. I've got 5x minus 5 over this. So I'm just going to do it here. Now I suppose what you need to know, the method basically says, well, we know what the answer's got to look like, because we know what adding fractions is. So the answer will be a over one of them, in this case x plus 3, plus b over the other one. And we just start off on that premise. We know it's going to look like that, just by experience of adding fractions so many times. And then if we do our trick where we add them together, you get a times by the x minus 2 plus b times by the x plus 3, all over that double bracket again. And the great thing about this is you'll notice here I've got 5x minus 5, x plus 3, x minus 2, and I've got here I've got this over x plus 3, x minus 2. You can kind of ignore the bottom and we just concentrate on the top. That's the equation that we're going to write down. Technically an identity, meaning it works for any value. Now the fact that it works for any value means I can pick nice numbers. And by that I mean nice numbers, I mean pick a number that makes my bracket equal to 0. And 2, take away 2, will make that bracket equal to 0. And the reason for doing it will get rid of these and it will tell me some information about b. So, but I have to put the 2 into the left-hand side as well. So 2 here goes 10, take away 5 is 5. That will be 0 when I put 2 in. This will be 2 plus 3 is 5, 5b. And so this has told me that b equals 1. Now pick a different number, x equals, now because this says x plus 3, I'm going to pick x equals minus 3. So if I put x is minus 3 into the left, I get minus 15 minus 5, that's minus 20. Again, put minus 3 into this, disappears, but minus 3 into this, I get minus 3 minus 2, it's minus 5a. And I reckon a then will be 1 as well. No, they're talking rubbish. A will be 4. Alright then, so my a is 4, so it's going back here, it will therefore be 4 over the x plus 3, plus the b is 1 over the x minus 2. And we just rewrite what's here in a nice last form. What's the answer say? Yes, that's right. So that's the first example done. Now here's another example for us. Now this just it looks as if it's different, but in actual fact, we know if we're going to get those, we must have started with a over the first one plus b over the second one, and after a while you get used to doing that. So what we're going to do, we've got 1. I didn't mean to do that, so I'm going to do my cross multiplication trick again. I'll get a x minus 1 plus b lots of x minus 3 over the x minus 3, x minus 1. And of course the whole point about this then is that thing equals this, and the bottoms are the same. That's why we're doing it. We can ignore it. So now it does seem appropriate to write 1 here, because that's what's left on top. So what we're going to do, what values for x? Well, I'm going to pick the first one. X is 3, it says. So when I pick x is 3, well, this 3 minus 3 will disappear. Well, that's great. The left hand side actually just says 1. That will be equal to 1. If I put 3 into this side, though, I'll get 2a. So it's not very nice. 2a is 1, so a equals a half. It's not as nice as before. What value should we pick now for x? Well, the second bracket says x minus 1, so change the sign, x equals 1. Put 1 into, well, actually 1 is still 1 on the left hand side. When I put 1 into this bracket, it will disappear. So I'm only left with this one. 1 minus 3 is minus 2. B. So B is minus a half. Now, technically then, I'm not going to like this. When I write this out, I'm meant to write a half over x minus 3, because it says a, and I found a to be a half, plus a minus a half, b was minus a half, over the x minus 1. Now that's not a very nice way of writing it, so instead of that we just tend to put the 2 on the bottom and multiply out. So it becomes 1 over 2 lots, and I could multiply out, I'm actually just going to leave it in brackets. Oh, plus and minus is just a minus, I'm pleased I spotted that. 1 over 2 lots of x minus 1. So I could multiply those out. No, I didn't in my bracket, my answer either. So on to the third one. Then this is exactly the same, apart from now I've got 3. Now I did show you adding them when you have 3, but we do the same set trick. X squared plus 6x plus 5 over the x minus 1, x plus 3, x plus 2. So what will I write? I'm going to write equals, well, identical to, well, it's a over the first one plus b over the second one plus c over the third one. And in the same way as when we added it before, we now are going to get a. Now, I suppose the trick here is to realize it's got to be over all 3 of them again. Now, the first one, a, is not over all 3. It's only over x minus 1, so it gains the other 2. It gains the other 2. So I'm going to write a lots of x plus 3, x plus 2, plus b lots of, well, it will gain the x minus 1 and the x plus 2, plus c lots of, and that will gain x minus 1, x plus 3. And again, effectively, I got this bracket over the triple bracket. I've got this lot over the triple bracket. I can ignore the bottoms. And I can just write x squared plus 6x plus 5 is identical to that lot. And it's identical, so I can pick whatever values I like. Pick a value. Might as well start with that one. X equals 1. Change the sign. 1 into this left-hand side goes 1 plus 6, that's 7 plus 5 is 12. 1 into this. Now look, that's why we're doing that. If I put 1 into that, that disappears. 1 minus 1, that disappears. That's the only thing that's left. If I put 1 into that, I get times by 1 plus 3 is 4, times by 1 plus 2 is 3. So that's 12. That's A is 1 then. So my first one done. Pick a different value. X equals, well, it says plus 3, so I'll choose minus 3. And what does that give me on the left hand side? That gives me 9 plus 6, that's minus 18 plus 5. What's that? That is 9 minus 4. 14, yes, that's right. Now, minus 3 then, if I put it into this one, it will disappear. If I put it into this one, it's the only one that's left is this middle one. So I get B times by, what's that? Minus 3 is X, so it's minus 4 times by minus 3 plus 2 is minus 1. Oh, that's interesting because that gives me 4B equals minus 4 or B equals minus 1. That gives me a second one there. I'm over here, I'm going to write the third one, so let's do, and obviously I'm going to now pick X as minus 2. So in the left hand side, if I do this, I get 4 minus 12 plus 5, and that's equal to, now minus 2, that disappears, only this is left, so it's C. Minus 2 minus 1 is minus 3. Minus 2, what's that say? Plus 3 is 1. So I reckon that's 4 minus 12, that's 9. That's minus 3 equals minus 3C, C equals 1. So I can now write this. A was 1 over the first bracket. B was a minus, so 1 minus 1 over the second bracket. And the last one was a 1. It was a really nice one, that one. Lots of 1s. So, yes, that's right. Oh, right. I've got the answer here to make sure we get the right there. So if you get one where the highest power on the top is the same or more than the highest power on the bottom, then you've got an improper fraction. And you can see that because if I multiply this out, I'll get x squared minus 2x plus, minus 8. And partial fractions only works if your highest power is on the bottom. So I have to do a job first, and that's long division. X squared minus 2x minus 8 has to be divided, and it does say divide here, so that's fair enough, divided into 2x squared minus 3x minus 32. We see how many times it goes in. And it's not hard to realise that 2x squared, I have to do times by 2 to get that. So 2x squared, 2 times minus 2x is minus 4x, and 2 times minus 8 is minus 16. And I put it in the bracket to remind me to take away. That disappears. Minus 3 plus 4 sounds like x to me. And minus 32 plus 16 is minus 16. So really, when I divide this, I get a 2. That's where this 2 comes from. But I'm not finished here yet, because this bit still hasn't been divided. And it's this bit that I do the partial fractions with. So x minus 16 has still got to be divided by the x minus 4, x plus 2. So let's do this quickly. I'll write that as a over the first one, plus b over the second one. I'll multiply it out, and I can't bother writing the bottoms. I'm just going to write on the diagonal, so it'll be a lots of x minus 2 plus b lots of x minus 4. And I then say x can be equal to the first one that it says up there is 4. So 4 minus 16 is minus 12. And if I put 4 into this, I get 4 minus, I get 2a. I've just realised I've made a mistake here. So this here is minus 32. Yeah, here's a mistake. That should be a plus 2. Sussed it. So that becomes 6a. That gives me a is minus 2. And if I do the same thing on the other one, x is minus 2. I get Yeah, I get b equal to 3. I'll quickly have done that there. So then I've got my 3 there. I've got my -2 there. It has all worked eventually after nearly making a mistake. So your job is to have a look at exercise 5C. There's lots of questions there. Try to do all 3 types in your work, and then you'll be ready.